Now, the chapters that I'm going to cover here is normal probability distributions. Okay, all of you type NPD in the chat box. NPD. Okay, descriptive statistics. Okay, descriptive statistics and measures of location, measures of variation. It is called dispersion. Okay, measures of central tendency. Example of central tendency: mean, median, and mode. Many of you might know. All of you type 3M in the chat box. Measures of central tendency: mean, median, and mode. Okay, and variation and dispersion. Okay, range and in variation dispersion, range, interquartile range, standard deviation, variance, and inferential statistics. Okay, there are two types of statistics: type IS and DS. Inferential statistics and descriptive statistics. Descriptive statistics, inferential statistics. You can type DS and IS or IS or DS or whatever it is. Okay, how do you describe a data? How do you infer from the data? Next, hypothesis testing, regression analysis, different sampling methods, examples of inferential statistics, difference between inferential and descriptive statistics, and 5-step approach, confidence interval, different tests that are used in inferential statistics, probability distribution. Okay, some examples, examples. Okay, and practice of basic probability. And how do you use that in Six Sigma analysis? Histograms, creating histograms in Excel, and normal distribution. Okay, how many of you are really charged to learn this? Type CHARGED, charged in the chat box, because this is only for people who are charged. If you're not wanting to learn all this skewed distribution, peak distributions, bimodal distribution, multimodal distribution, edge peak distribution, truncated distribution, normal distribution, characteristic of a normal distribution, importance of that, some empirical rules, why assess normality, what is normality, and what are the tools that we use to assess normality, how do you do normality testing in Excel sheets, you know, and descriptive statistics of data, how do you set up hypothesis, the chi-squared goodness. My God, all of you type my God in the chat box. And these are the things that I'm going to passionately share with you. Oh my God, OMG. But isn't it interesting to learn all this? I've gone through each and every minute detail of the headings to really, you know, make sure that you get maximum value. How many of you can see this? Type ICS, I can see in the chat box, because I want to leave this community much better to be able to solve problems in the workplace. And that's why I worked hard on myself so that it becomes easier for you. I really thank all of you for having attended today. All I request is, you might feel overwhelmed with many of the topics, but without commitment, you can never start. And more importantly, without consistency, you will never finish. How many of you agree with me? Type agree. How many of you super agree with me? Type SA, super agree in the chat box. Commitment and consistency is very, very important in that. Even though it is moving to the, if you are moving to the uncomfortable zone, because this will pull you into uncomfortable zone, but go to the learning zone after that, so that you will go to the growth zone. Okay, and people, I invite all of you to click on this link and come to my upcoming webinar and get certified, because this is one of the most valuable things that you would learn. Okay, now normal probability distributions. You see here on this graph, this is called exponential distribution. This is called as a normal distribution. Okay, these are all continuous distributions, because continuous variables like time, temperature, that is called continuous distributions. There are some discrete distribution called binomial, geometric, and hypergeometric distributions. Now, don't worry about this distribution, but all I want to say is there are different types of distributions. Now, in the last chapter, how many of you were there during last session? They just type LS in the chat box. I have taught you how to download analysis tool pack in this. Okay. So I have taught you, if you have not attended my last session, I will share with you the presentation today. Okay, I'll give you access to that presentation. In the presentation slide, there are clear steps on how to download analysis tool pack in the Excel. Okay. So in this chapter, we'll discuss how and when to use normal probability to draw inferential statistics. Okay. Now is a good time to know the difference between descriptive statistics and inferential statistics. Descriptive statistics describes the data. Inferential statistics, we take samples and infer the lot. Okay. There is a big lot. We take a small sample out of this and then we can infer the lot whether it is similar to the sample or not. Like the exit poll, we take the sample, we conduct interviews on whom you voted for, and then we infer which party would win. Okay, if it is clear on a scale of 1 to 10, please give me a 9 or 10 with this simple explanation. Okay, if it is clear about what is inferential statistics. All right. So descriptive statistics. Let us go into the depth of descriptive statistics now. Let's pay close attention here so that we don't miss out. If you're distracted by something, you will miss the bus. So please pay close attention. Descriptive statistics are numbers used to describe a set of data. How do you describe the set of data? Given a set of data about employees in the company, let's see the employees in the company. Okay, some might say over 50% of the employees work in sales and marketing department. Okay, or 86% of the employees live in the same PIN code, okay, that the office is located in. So these are all some data that describes the data. Okay, these are all descriptive statistics because they simply discuss the nature of the data at hand. Okay, now average or means, standard deviations are associated with data are all descriptive in nature. Okay, now if I have to go into a detail of this descriptive data, all of you type 3M, mean, median, mode, because there is something called as mean, which is average of data. There is something called as a median, which is the midpoint of the data. And there is something called as a mode, which is the modal points, the frequently occurring numbers. Okay, those are all the things that describe the data. Okay, there are people who are, if you see the weight of the class, there are people who are 50 kgs, there are people who are 60 kgs, there are people who are 45 kgs, 80 kgs, 90 kgs. You can ask, hey, what is the average or the mean of that? So that is describes the data. Okay, let me go deeper, little deeper into that. We will review the descriptive statistics shown here, which are commonly used. Now, measures of location or central tendency. Okay, all of you type CT in the chat box. Okay, central tendency. Average is an indication of the central tendency of the data. Median is an indication of the central tendency of the data. Mode is an indication of the central tendency of the data. It requires a average is the central tendency because somebody is 30 kg, somebody is 60 kg, so on average 45 is in the center. So that is called as a central tendency. Now variation, there are a lot of things for variation. For example, range is the variation, maximum minus minimum. Somebody is 30 kg, somebody is 60 kg, that is a range which is 30 kg. Okay, and there can be a standard deviation. There is something called as a interquartile range. Okay, there is something called as variance. All that we will talk about. So the central tendency is mean, median, and mode. We will explain this mean, median, mode. We will tell about how it describes the data, how it is useful to us in analyzing the data, in knowing more about the data. Because data or raw data is a set of numbers, okay? But if you want to analyze here, the starting point is what is the central tendency? What is the average of it? What is the median of it? What is the mode of it? Which is the better indication of the central tendency is something we will study. Okay, if you see here, dispersion, measures of dispersion. Okay, now all of you type MOD in the chat box. You type the CT, which is central tendency. Now measures of dispersion. This is a little complicated, okay, because they will indicate the way it is spread out. Okay, the way the data is spread out. I normally explain this with something dropping the marble at the center of the circle. Okay, suppose imagine that you are in a large hall. Okay, you are at the center of the hall and you draw a big circle around you and you have a handful of marbles. You drop the marbles at the center. What will happen to those marbles when you drop it? When you drop 100 marbles from a bag, what would happen to the marble? Just let's have some conversations before I get into this dispersion. What will happen to the marble? Just type on the chat. It will spread out. Okay, good. There is a word called they scatter. Very good. Scatter is another word. It will disperse. Disperse is another word. It will move away from the center in different directions. That is another word, etc., etc. Okay? Okay. The point here is this. The point here is that I want to communicate here is every marble will have some distance from the average. Okay. On an average, the marble may be towards the center or slightly away from the center, but every point is dispersed from the center. Okay, so the marble, one marble is called x1, x2, x3, x4, x5 up to xn or 100 marbles are there. Okay, now on an average the marble can be at a particular location, that is called x bar. Okay, that is called x bar. So what is the distance between this average point to x1? What is the distance between this average point to x2? So x average minus x1, average minus x2, average minus x3, average minus x4. You actually square them, add them, and divide it by n or n minus 1. I'll talk about that. That is a measure of dispersion. Okay. If you are clear with this example to some extent, please give me a 9 or 10 if this example is clear. And we will go into several such examples like this. And if it is super clear, it's really bulb on moment for you, type BON, bulb on. Oh, this is something that's a great example or something like that. Okay. Super. Okay. Now let me get into the depth of it. So the measures of variation or dispersion is range, interquartile range, standard deviation, variation. Okay, these are the measures of variation. All of you take good notes. Range, interquartile range, standard deviation, and variation. And standard deviation and variations are connected because the square root of variance is standard deviation. Okay, and interquartile range is also something that we will explain. Okay, so please write in your notes range, variance, standard deviation, and interquartile range. That describes the data. So I would want to rewind by saying there is a measures of central tendency, which is mean median mode, central tendency, which is the central tendency, and which is also called measures of location, and measures of dispersion, which is the range, interquartile range, standard deviation. And range and standard deviation are widely used, and interquartile range is used in one of the type of plots called box plot. Okay, so with that we will proceed. Measures of central tendency. Now this is a cricket season. How many of you watched the final cricket match? Type me in the chat box. Whoever has watched the final cricket match. Cricket lovers? Yeah. Okay, the final match was in Dubai between New Zealand and India, right? Okay, and we won the Champions Trophy. So nice. Okay, in any game, somebody wins, somebody loses, but it's just enjoying the game that is important. Good. Okay. We are interested in cricket, but have you ever wondered during the match why the run rate of a particular over is projected? What does the run rate means? Anybody just you can share your thoughts. What does the run rate mean? Suppose if you say, oh, the current run rate is 4.7. It's an average. Correct. Runs per over. It's an average. Excellent. It's not variation from actual. It is average. Okay. It is average. Okay, fine. Or when you get your examination card results, you mention the aggregate percentage. What does this aggregate percentage means? You get some 75% in languages, 80% in mathematics, okay, 90% in chemistry, average, right? This is the meaning of the aggregate. Okay, awesome. Average. Okay, aggregate is not total. Okay, aggregate means it is total divided by the number of subjects. Okay, now all this quantity in real life, all this quantity in real life makes it easy to represent the collection of data in terms of single value. It's called statistics. Okay, all of you type the word statistics, which is very, very important. And my request is don't be scared of statistics. I'll make statistics simple. Okay, I'll make statistics very simple. And by the way, I've also done MSc honors in mathematics. Okay, from BITS Pilani. I've done BE honors mechanical, MSc honors mathematics, MTech in technological operations, MBA in finance, and MBA marketing, and doctorate in lean methodology. And I know how hard it is to understand concepts. My mission is to make the concepts very, very simple for you to comprehend. Okay. All right. Measures of central tendency is statistics deals with the collection of data and information for a particular purpose. The tabulation of each run for each ball in cricket gives the statistics of the game, because we will put for the 4th over, 6th over, 7th over, each ball we will also give the tabular column. Okay, this ball is white ball, this is 2 runs, this is 3 runs, this is 4 runs, etc., etc. The tabular columns. Okay, the representation of such data can be done in multiple ways through tables, graphs, pie charts, bars, etc. We have seen this sort of different graphical representation in our earlier chapters. The measures of the central tendency are given by various parameters commonly known as mean, median, and mode. We have seen mean, median, mode, right? We have spoken about it. Now, I'm going to explain about what is mean, median, mode. Now, the data, when it is represented, if you have 100 data points, and if it is a perfect symmetrical distributions, for example, if I'm seeing the average marks in the class is, let's say, 70%, and there is 50% of the people below 70% and 50% of the people above 70%, or the average marks in the class is 60%. There are 50% of the people who are less than 60%, and there are 50% of the people who are greater than 60%. Then it will be a perfect normal curve that is a symmetrical distribution that you see in the center. If this is clear, type SC, super clear, in the chat box. Now, what I want to communicate with this, through this, what I want to communicate here is this. Okay, number one, if you take the average also, if you take the median also, if you take the mode also, all will be the same value. In a perfect symmetrical distribution, the mean, the median, mode, all are same. Okay, whereas if it is either positive skewed or negative skewed, like you see here, the mean can be somewhere here, the median can be here, the mode can be here. If you see in the negative skew, mode is on the right side, the median is somewhere here, and the mean somewhere here. Okay, I've just pictorially represented it. Those of you who are able to comprehend well of what I've written here, give me a 9 or 10 if you are able to comprehend well on what I've given here. Okay, so measures of central tendency is a representation of various values given in the data set. Okay, there are various measures for central tendency. The most important thing is now I will introduce the symbols for it, which is mean, which is X bar, which is also called average, median, which we call, it's also mentioned as mu, okay, the symbol mu, and the median, which is capital M, and the mode, which is Z. Okay, now you might be wondering which symbol to use for mean. Okay, now the reason that we use the two symbols here is, one thing represents the large data set which we call population, and one X bar is actually representing a smaller data set which we call sample. The large data set is called population. The smaller data set out of that large data set is called sample. Sample averages are represented by X bar, and the large data set population average is represented by this Greek letter called as mu. Okay, if this is clear, type CC, crystal clear, in the chat box. And with that, let me move further into that mean median mode, which is the measures of the central tendency. Super. Thank you very much. Don't miss to come to my upcoming webinar and get your certification. Okay, certification will be shared in the upcoming webinar on how to get your certification. Okay, so examples of central tendency is, say, 50 over one-day international match between India and Australia, or India and New Zealand. Okay, India scored 370 runs by the end of the first innings. Okay, how do we decide whether India put a good score or not? It's pretty simple, right? You find the overall run rate for which it's good for you to score, and thus here comes the concept of median mode. So you can always calculate the run rate, and if that run rate is possible to achieve, then that we mean that it's not a very challenging score. Difficult to achieve means it's a challenging score. So we always calculate the average runs per over, which is the run rate, and try to calculate that. Okay, let us learn in detail about the central tendencies in the subsequent things. Okay, now I have got into the detail. Okay, here if you see the central symmetrical distribution, the mean is equal to median is equal to mode. Whereas if you see on the negatively scored, okay, the mean is smaller, the median is there, and the mode is. And here if you see on the right side positively skewed, mean is greater than the median, greater than the mode. If this is clear, type SC super clear in the chat box. It doesn't need much explanation. But it's, if the data represent like this, then accordingly medians and modes will vary. Too much about these three, because most of it, 95% of the time, we use only mean, which is equal to average, and mean and average are the same. Okay, now mean, so many runs per over. Okay, x1, x2, x3, x4, which is xn. Okay, each of the overs you have the run total, n is 50 overs, divided by n is x bar, which is the run rate. Okay, if you want the average weight in the class, weight of first person, second person, up to the 50th person, divided by 50 is the average. So the measures of central tendency, mean or mu. Mean is mostly commonly used measure of central tendency. Mean actually represents the average of the collection of data. It is applicable both for continuous and discrete data, and it is equal to the sum of all the values in the data collection of data divided by the total number of values. Okay, this is super simple. All of you type simple in the chat box, because calculating average is, you would have done n number of times. It's the most simple thing to calculate. Okay, now let's go to the next two measures of central tendency, which is called as a median. The second one is called as the median. For those who don't know the median, I will explain you. Median represents the midpoint of the given set of data when it is arranged in the particular order. For example, if you wanted the average height of people in your classroom, average height of people in your classroom, if you want to calculate the average, you measure the height of each and every person. Let's assume that there are 100 students in the class. Each of their height you measure, add all the heights, divided by 100 will be the average. Whereas if you want to find the median, you will not add anything. You ask them to stand in the height order. Okay, you can ask them to stand in the height order. How many of you remember your school days where in the sports ground you were asked to stand in the height order? Type me in the chat box if you have actually gone through that experience. You know, all of you stand in the height order. Everybody stands in the height order, right? So if you, fantastic. Okay, so far if you are finding it interesting, useful, valuable, fantastic, awesome, put it in the chat box. Okay, I wanted you to enjoy the statistics. Okay, I wanted to have a lot of fun learning the statistics. Okay, that's very, very important. So you stand in the height order, and as a sports person, I pick the middle guy. Okay, I pick the middle guy, and that middle guy height I measure, that is the median. Median is the middle guy. Middle guy or girl. Okay. Median is a middle guy. If it is simple or super simple, type SS in the chat box. Super simple in the chat box. Now the question is, if there are 7 guys, what is the middle number? If there are 7 guys, what is the middle number? Fourth guy, okay? 7 guys is not 3.5. If there are 7 people who are standing, okay, the fourth guy is the middle guy because before him, in front of him are the 3 people, back of him is 3 people. Okay, so the fourth guy is the middle. Suppose if it is 8, which is the middle guy? Suppose there are 8 people, which is the middle guy? Okay, right. 4 to 5, right? Okay, now that's what I'm going to explain here. How many of you can see my screen clearly? Okay, type clear in the chat box if the screen is clear to you. If you can see my screen full and clear. Okay, right. Because some people probably their Zoom settings you need to change in such a way that you are able to see the screen. Okay, so given that data collection is arranged in the ascending or descending order, the following method is applied. Okay, now I'll share with you this. Okay, this formula is very simple. If there is 7 people, okay, 7 plus 1 divided by 2, what is that value? 7 plus 1 divided by 2, 4. Okay, that is the fourth guy. Okay, good. So that fourth guy's height is the mean. Okay, so similarly, you can apply this for the even number. If it is even number by 2, the term by n by 2 plus 1, which means that if it is 8, okay, you go fourth and fifth, you add that and divide it by 2 for the median. The height of the fourth person, the height of the fifth person divided by 2 is the median. Okay, if it is clear on a scale of 1 to 10, please give me a 9 or 10. If it is super clear, this is most simple. And the last one is a mode, which is the most frequently occurring number. Okay, most frequently occurring number. For example, the marks obtained by these guys, Anmol, Kush, Garima, Ashwini, Geetika, and Sakshi. Okay, what is the mode in this? What is the mode in this? The most frequently occurring number. Okay, mode is 73, right? Average you can calculate. And if you want to calculate the median, you need to put something like, okay, 70. Totally there are 1, 2, 3, 4, 5, 6 are there. So 70, okay, 65 first, 70 next, 73, 73, 73, and 80. You need to arrange in this descending order: 65, 70, 73, 73, 73. And the median is 73 plus 73 divided by 2, which is 73. In this case, is the median and mode are same. Okay. I don't know, mean can also be same. I have not calculated. Anybody can calculate the mean and tell me. Okay. Okay. So the maximum frequency is 73, so 73 marks. So mode of this is 73. It is possible to have multiple modes. It's called as a bimodal distribution.